Good evening, Sir Mark Jerome de la Peña. My name is Oldarico Campo from BS in Math 2A. So, at this moment, I will just discuss our project in Math 123 in Calculus 1 with Analytic Geometry under the conic section. So, our group is assigned to create a miniature of any landmark that shows an ellipse. After that, we will make a real-life problem situation about the miniature or the landmark that we have been chosen. And our group chooses the Grand National Theater of Beijing, China as our model of our miniature. The Grand National Theater of Beijing, China, in the center of Beijing, only 500 meters from the Forbidden City and Tiananmen Square, the National Grand Theater building emerges as an island of culture in the middle of a large artificial lake. A titanium shell in the shape of an elliptical dome forms at once roof and facade and clads a radial metallic triangular structure with spans ranging from a minimum 144 to maximum 213 meters. Next slide. We built a miniature model of Grand National Theater. The miniature we made was 8 inches high from the ground and 10 inches wide at the center of the elliptical building itself. The elliptical shape of our miniature is made of tire wire and tin foil, a grass that serves as the trees, and plywood as our base. We also use styrofoam in creating the stage of the performance stage, and a color blue paint as the water and a silver paint as a pathway to the theater hall. Next slide is the actual photo of our landmark. Next is the photos of our miniature in front view, the back view, the sides, and lastly is our top view of our miniature. Next slide are the materials that we used are paint, poster color, paintbrush, foil, glue stick, plastic grass, and a tire wire. As you have seen on the next slide, on the left side is the sketch of our handmade, and on the other side is the sketch of computer generated. At the center of this theater is the opera house, and on the left side is the concert hall, and the other side is the Chinese theater. Next is the graph of our handmade and the graph of computer generated. Next slide is our equation. The National Grand Theater miniature is a horizontal ellipse. Our center is HK is at the origin. After measuring the major axis, which is 20 inches wide from the elliptical building itself, and the minor axis, which is 16 inches high from the elliptical building itself, we solve for the value of B from the center to co-vertices, which is equal to 8 units. Since we already have the value of A and B, we can now solve for the height of the ceiling to the center stage of the concert hall, which is equal to 5.40 inches. Next slide, we will just enumerate the given values of A, B, C, and our center, which is HK, and then A is equal to 10, B is equal to 8, C is equal to 6, and our center, which is HK, is equal to 0, 0. Next is our standard equation. So this is a type of horizontal ellipse. We will just simply use the formula of x minus the quantity of x minus h squared over e squared plus the quantity of y minus k squared over b squared is equal to 1. Just simply substitute the given values of the center, which is 0, 0. Therefore, it will become to the quantity of x minus 0 squared over 10 squared plus y minus the quantity of y minus 0 squared over 8 squared is equal to 1. So this is now our standard equation. Next is our general equation. X squared over 10 squared plus y squared over 8 squared is equal to 1. Just simplify. X squared over 10 times 10 is equal to 100. 100 plus y squared over 8 squared is equal to 64, equal to 1. At this moment, we will just think their common product, and that is 1,600. Just multiply to both. 1,600 times x squared over 100 is equal to 16x squared plus 1,600 times y squared over 64 is equal to 25y squared is equal to 1,600 times 1 equals 1,600. Just equate this to 0 to make our general equation, and it becomes to 16x squared plus 25y squared minus 1,600 is equal to 0. It becomes negative because from the right side, we just transpose 1,600 to left side, meaning from positive, it will change the sign into negative. That is why it become minus 1,600. Next slide is our situational problem. The Grand National Theater is located in Beijing, China. Is a titanium shell in the shape of an elliptical dome with a width of 20 inches. It consists of 3 performance halls: the concert hall, which is located on the left side of the theater, the opera house at the center, and the Chinese theater on the right side. The stage center of the concert hall is located 12 inches to the west of the stage center of the Chinese theater. If the stage center of the concert hall is 1 inch from the floor, how high is the ceiling from the stage center? So here is our question, and here will we are finding for the height of the ceiling from the stage center. If the stage center of the concert hall is 1 inch from the floor. Next slide. Here is our illustration. As you can see, the opera house is on the center, and on the left side is the concert hall, and on the right side is the Chinese theater. So the height of this to the ground is 8 inches, and then the width is 20 inches. Next slide is our equation. This is the equation of a horizontal ellipse. The quantity of x minus 0 squared over 10 squared plus the quantity of y minus 0 squared over 8 squared is equal to 1. So to solve for the problem is to find the height of the ceiling from the stage center of the concert hall. To solve this problem, we need to relate the situation into a graph and use its equation. Since we don't have the height of the Grand National Theater, we need to find the value of b. We have the equation b is equal to the square root of a squared minus c squared, wherein our a is equal to 10 and c is equal to 6. Just direct substitute the given values. It will become to b is equal to the square root of 10 squared minus 6 squared is equal to 10 squared is equal to the square root of 10 squared is equal to 100 minus 6 squared is equal to 36 equals 6 equals to 100 minus 36 is equal to the square root of 64. Therefore, our b here is 8 because the square root of 64 is 8. Next, now that we have our b, which is 8 units, and the center is 0, 0, our final equation is x minus 0 squared over 10 squared plus the quantity of y minus 0 squared over 8 squared is equal to 1. Since we are looking for the height of the ceiling from the stage center of the concert hall, which is our y, hence the value of x is negative 6. We can use the equation x minus 0 squared over 10 squared plus the quantity of y minus 0 squared over 8 squared is equal to 1. Therefore, it will become 6 minus 0 squared over 10 squared plus y minus 0 squared over 8 squared is equal to 1. So 6 minus 0 is equal to 6 squared over 10 times 10 squared is 100 plus y minus 0 is equal to y squared over 8 squared is equal to 64 equals 1. 6 squared is 36, copy 100 plus copy the y squared over 64 is equal to 1. Y squared over 64 is equal to 1 minus 36 over 100. In this part, we just simply remain the rational form that has a variable, and then what we will transpose is the non-variable rational form, and then after that we will just copy y squared over 64, and then y minus 36 over 100 is equal to 0.64. After that, we will just multiply both sides, their common factor, which is of the denominator, which is 64. So 64 times y squared over 64 is 64y squared over 64. 64 divided by 64 is 1. What will remain is y squared only, is equal to 64 times 0.64 is equal to 40.96. Positive, it will become positive or negative. At this time, in order to remain the y only, we will just square both sides. Square root of y squared over is equal to positive or negative square root of 40.96. So we have a possible two answers here, wherein the other one is positive and the other one is negative. So cancel the squared. So what will remain is y only, and then is equal to the square root of positive or negative 40.96 is equal to positive or negative 0.64. So 0.40. So we will just choose the positive one. Y is equal to 6.40 inches. Since the stage is 1 foot high from the floor, we have to subtract 1. Therefore, y is equal to 6.40 is equal to 1, and it will become to y is equal to 5.40 inches only. To check, as defined in ellipse, our d sub 1 plus d sub 2 is equal to 2a. To solve for d sub 1, given p is equal to negative 6 and 6.40, and the foci 1 is negative 6, 0. So to find the distance 1, the square root of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared is equal to, just simply substitute the given values, negative 6 minus negative 6 squared plus the quantity of 0 minus 6.40 squared is equal to the square root of 0 plus 40.96 is equal to the square root of 0 plus 40.96 is equal to the square root of 40.96. The square root of 40.96 is equal to 6.4. Therefore, our distance 1 is 6.4. So, it is true. And to solve for D, our P is negative 6 and 6.40, and our foci 1 is 60. So, to solve for the distance 2, we will just simply use the formula of x sub the quantity of square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. Just simply substitute the given values. Square root of the quantity 6 minus negative 6 squared plus 0 minus 6.40 squared is equal to the square root of 12 squared plus negative 6.40 squared is equal to the square root of 144 plus 40.96 is equal to the square root of 184.96. Therefore, the square root of 184.96 is 13.6. This is now our D sub 2. And now, we will just add the distance 1 and the distance 2, which result to 2a. So, just simply direct substitute the given answers of D sub 1 and D sub 2, or the answers of the distances, which are the 6.4 of D sub 1 plus 13.4 of D sub 2 is equal to 20. So, just simply add 6.4 plus 13.4 if it equals to 20. Therefore, 6.4 plus 13.4 is equal to 20, and copy 20. So, they are equal. To conclusion, therefore, the height of the ceiling of the stage center is equal to 5.40 inches. That's all. Thank you for listening, and good luck to me.